America's iconic Yellowstone National Park was closed for the first time in 34 years.
The geologic history of Yellowstone goes back to the formation of the North American continent.
We're looking at this deposit from a super eruption, and yet we're over 50 miles from the source of the eruption.
Yellowstone Park has just been closed, with the risk of an eruption skyrocketing by 320%. This shocking development has left truth seeker Tucker Carlson in a panic as nearby communities evacuate at an alarming rate. Scientists are racing to provide crucial information to help us prepare for a disaster that now seems about to occur. What's keeping Tucker Carlson on alert following this alarming Yellowstone volcano update? Join us as we delve into why this may be just the first warning of a potentially devastating natural disaster. The unseen dangers of Yellowstone. The recent discovery of a 100-foot-long crack near Hidden Falls in Yellowstone National Park has raised alarms about the possibility of the park's supervolcano erupting sooner than expected. Yellow is typically calm, but beneath it lurks powerful volcanic forces. The contrast between its peaceful landscapes and the potential for catastrophic eruptions has become a major topic of discussion. This recent geological finding has intensified concerns, leading to the park's closure and heightened scientific monitoring. Experts and local authorities are working tirelessly to understand and mitigate the risks, emphasizing the need for public safety and awareness. As research continues, the relationship between the park's beauty and its underlying dangers is redefined, reminding us of nature's unpredictable power. Yellowstone itself is a giant natural system powered by underground volcanic activity. This activity is the driving force behind the park's famous geysers, hot springs, and mud pots. The heat from the volcano heats the water that erupts from the geysers and creates the bubbling mud in the pots. This entire park owes its beauty and unique features to the underlying volcanic activity. The landscape of Yellowstone has been shaped over thousands of years by this volcanic force. The natural beauty we see today has been carved by past volcanic activity, which continues to change and form the land. The crack, while significant, is just the latest sign of the ongoing natural processes that define Yellowstone. In terms of safety, while the idea of a supervolcano eruption is scary, the actual probability of such an event happening in our lifetime is very small. Geological changes usually occur over long periods, much longer than a human lifespan. The percentages and risk factors mentioned in the reports are based on scientific data, but they don't always mean an eruption is just around the corner. Despite these reassurances, the mention of a 320% increase in risk does cause worry. It's important to understand what this number really means in a practical sense. It's based on scientific models and calculations that are meant to help researchers understand potential risks, not to predict exact outcomes. Yellowstone's supervolcano has the power to change landscapes drastically. This is a fact that adds a serious tone to any discussion about cracks and changes in the park. Yet, it's also a chance to appreciate the incredible forces of nature at work. The park's ongoing changes are a reminder of the Earth's dynamic nature. So, while the crack is an important discovery that requires close monitoring, it is also part of a larger, continuous story of natural change. This story involves not just potential destruction, but also the creation of new natural features and landscapes. Understanding these processes helps us respect the power of natural forces and prepares us for living alongside them, recognizing both their dangers and their contributions to the natural world. Yellowstone National Park is a unique type of volcano. Rather than a typical mountainous structure, it contains a giant underground pool of molten rock known as a magma chamber. This chamber is the primary source of the park's heat, responsible for its famous geysers and hot springs. Established as the world's first national park in 1872 by an act signed by President Ulysses S. Grant, Yellowstone was created to protect this extraordinary landscape from being exploited for commercial purposes. The idea to establish such a park was largely due to the efforts of individuals like Ferdinand Vanderveer Hayden, Senator Samuel Clark Pomeroy, and other conservationists. They argued that the land should be preserved to maintain its natural beauty for future generations. The year before the park's establishment, Hayden and his team, which included William Henry Jackson and Thomas Moran, explored the area. They provided Congress with reports and sketches of the land, highlighting its beauty and potential importance for science. This was at a time when the U.S. government was expanding its territory westward, and the existence of such a unique landscape was largely unknown until Hayden's exploration brought it to attention. However, it seems that Hayden and his team may not have fully recognized the significance of the volcanic activity beneath the park. While they documented the geothermal features like geysers and hot springs, the idea of a massive active volcano under Yellowstone might not have seemed likely or important to them at the time. Yellowstone's beauty hides powerful forces rumbling below. The hidden dangers of Yellowstone. It wasn't until decades later, in 1960, that the scientific community began to understand the true nature of Yellowstone's geological features. With the advent of better technology like seismographs, researchers were able to measure the tremors beneath the Earth's surface, discovering the huge, active magma chamber. This shifted the understanding of Yellowstone from just a natural beauty spot to a critical site for geological research. The park now serves as both a stunning example of natural wonders and a vital point for studying volcanic and seismic activity. This dual role adds to its significance, showing it as a place of immense natural energy and a critical spot for scientific observation. Small tremors were detected, indicating that something significant was moving beneath the Earth. This movement was not just any ordinary geological activity, but was specific to the magma found beneath Yellowstone's volcano. Further observations showed that the Earth's surface was not just shifting irregularly, but exhibiting a pattern of rising and falling movements. These movements suggested that the volcano was not just a static feature in the landscape, but an active and potentially threatening force. The fact that Yellowstone is home to a supervolcano was not widely recognized until the middle of the 20th century, despite the presence of the volcano itself for much longer. It was during the 1960s when a geologist named Robert L. Christensen, who worked for the U.S. Geological Survey, was mapping the expansive terrain of Yellowstone. During his work, he discovered an immense caldera, a huge volcanic crater that measures between 30 to 40 miles in diameter. This caldera was formed from a massive volcanic explosion that had occurred roughly 640,000 years ago. This discovery highlighted the extensive scale of volcanic activity that could potentially occur again. This large caldera clearly indicates the immense power of natural forces capable of altering landscapes dramatically. Although the term caldera may sound technical, the reality it represents is anything but simple. It originates from a massive eruption that propels ash and debris several miles into the sky, causing widespread destruction. Recognizing the caldera helped confirm the daunting reality that Yellowstone's volcano is an active supervolcano quietly brewing beneath the park's beautiful scenery, and it could awaken with destructive results. The presence of this supervolcano sparks interest and genuine concern. Monitoring the slight fluctuations in the ground and the faint seismic activity from below the surface is not merely a scientific routine, it is essential for predicting future eruptions. Each minor vibration and sound could potentially be an early warning of a much larger disaster, making the continuous study at Yellowstone a careful and constant guard against one of nature's most powerful threats. Understanding this, researchers and scientists persist in their vigilance, carefully analyzing every bit of data from the seismic monitors. Their work is vital, aiming to provide early warnings that could save lives and mitigate damage should the supervolcano erupt. This ongoing research underscores the importance of being prepared and maintaining a respectful awareness of the powerful processes at work beneath Yellowstone, which remain largely hidden yet profoundly influential on the surface world. To confirm that Yellowstone is indeed a supervolcano, researchers have examined geological evidence from across North America. They found that large amounts of volcanic ash trace back to Yellowstone. This ash isn't just a small layer. It covers big areas and highlights the extreme size of the eruptions that occurred. Scientists discovered an intriguing range of dates when this ash was closely studied. Some samples of the ash are as old as 2.1 million years, while others date back to about 640,000 years ago. The difference in age suggests that Yellowstone has witnessed 3 significant volcanic eruptions over its history. The oldest eruption, from 2.1 million years ago, sent ash as far as the Gulf of Mexico. Imagine ash from New York reaching Dallas. That's the scale we're talking about. This widespread ash indicates an eruption of staggering magnitude, far greater than any volcanic activity seen in recent history. The discussion around these eruptions often sounds disconnected from their potential danger. Yet, the reality is anything but theoretical. Each layer of ash deep in the soil serves as a clear signal of the Earth's capacity for devastating events. Now, the best part, let's explore the notable volcanic eruptions that have shaped this landscape. Starting with the Huckleberry Ridge eruption, which occurred about 2.1 million years ago, this event was monumental, producing an extensive layer of volcanic rock known as Huckleberry Ridge tuff. It reshaped large areas of the landscape that we see today. Following Huckleberry Ridge, the Mesa Falls eruption occurred 1.3 million years ago. Though it was smaller than its predecessor, it still had a significant impact, creating the Mesa Falls tuff. This layer, while not as extensive as Huckleberry Ridge, adds to the layered geological history of the park. The most recent major eruption, the Lava Creek eruption, happened around 640,000 years ago. It was the smallest of the 3, but still important, forming the Lava Creek tuff. Together, these eruptions have built up the park's current landscape, including a multi-ring caldera, a series of large volcanic craters formed by the collapse of land following an eruption. The caldera that we see today at Yellowstone is not just a scenic point, but a complex geological feature formed over thousands of years through multiple eruptions. Each eruption has contributed to the depth and complexity of the landscape, layering tuffs and altering the terrain. Yellowstone's geysers hint at deeper volcanic activity, unstable cracks in the earth. Beneath the surface of Yellowstone, a giant network of underground channels extends well beyond the park. These channels are crucial as they are the lifelines for the park's geothermal activity, fueling features like geysers and hot springs. One of the most lethal geothermal areas is the Norris Geyser Basin, known for its extreme heat. In this part of the park, temperatures can soar above the boiling point of water. This area once recorded a ground temperature of 200 degrees Fahrenheit, illustrating the intense underground activity. The extreme temperatures at Norris Geyser Basin are not solely due to the heat from the magma below. They also result from the interaction between volcanic gases and boiling underground water, which makes the water extremely hot and the surrounding environment highly acidic. The Norris Geyser Basin is as old as Yellowstone's volcano, perhaps even older. This area has existed for around 115,000 years and has developed numerous geysers over this time. One of these is the Steamboat Geyser, recognized as the tallest active geyser in the world. It can shoot water up to 400 feet in the air, much higher than Old Faithful, though it's far less predictable in its eruptions. Recently, Steamboat has become particularly active, with 9 eruptions recorded in just 3 months. Nearby, the Aquinas Geyser is known for its unusually acidic waters, which is quite uncommon among geysers. The Ledge Geyser stands out for the volume of its eruptions, producing sounds that resonate loudly across the basin, akin to rolling thunder. Meanwhile, the Minute Geyser is notorious for its sudden, frequent bursts that can happen without any prior signs. Scientists have found that the behaviors of these geysers are deeply connected to the magma channels beneath the Earth's surface in Yellowstone. These channels supply the heat and pressure necessary for the geysers to erupt. The different characteristics of these geysers, such as how high they erupt, how often they do so, and how loudly they sound, are all influenced by these underground magma channels. This direct link to the volcano's internal processes explains why the geysers act the way they do, from the towering blasts of Steamboat to the unpredictable eruptions of Minute Geyser. The Norris Geyser Basin is a powerful example of nature's inherent force, constantly shaped and reshaped by the geological activity below. It showcases the delicate balance between creation and destruction that exists within Yellowstone, reminding us of the potent forces that can lie hidden just beneath the surface. Yellowstone National Park is known for its beautiful scenery and natural features, but beneath it lies a supervolcano, a huge volcano that poses significant risks. This giant gets its power from heat deep within the earth. Now, let's focus on the serious risks it brings. Recently, a large crack has formed that forced the closure of Big Oak Flat Road, a key road through the park. This isn't just a problem for travelers, it's a clear sign of the dangers hidden beneath the park's surface. Over the years, there have been many small signs that the volcano might be getting ready to erupt. These signs show that the threat of an eruption is real and needs close monitoring. What does this crack mean? It's important because it shows that big changes can be triggered by small events. This crack might be an early warning of larger events to come. Every new crack in the ground and every change in the park's heat springs are clues that the volcano is becoming more active. The people who manage the park and the scientists who study it are concerned. Although they work hard to keep the park safe and keep people informed, the truth is that this supervolcano is unpredictable. Even with modern technology, we cannot control or predict everything about it. We depend on understanding signs from nature, which operate on a scale and timeline far beyond our usual experience. So, while park officials repair roads and try to reassure visitors, we must consider how ready we are for the possibility of a major eruption. The road's closure and the crack's appearance are not just practical problems, they're reminders of the powerful natural forces at work. These events should make us think about our preparedness. Each small sign of activity from the volcano tells us more about what could happen. We watch these developments not just because they are interesting, but because they are critical to understanding how to respond to potential natural disasters. As we watch and wait for what the volcano will do, we are reminded of our vulnerability to Earth's ancient, powerful processes. The question remains, how will we handle it when the volcano awakes? This ongoing situation at Yellowstone is a serious matter, urging us to consider our response to natural events that we can observe but not control. Each step in the volcano's activity is a step closer to understanding and possibly predicting its future behavior, but also a step toward recognizing the limits of our control over nature. There's a noticeable change with the Steamboat Geyser, which is the tallest of its type. Normally, it would erupt once or twice a week, but this frequency has started to increase. In the year 2018, the geyser erupted 32 times, and by 2019, this number rose to 48 eruptions. This trend of increasing eruptions continues to grow, suggesting something unusual is happening. The rise in eruptions could be due to several straightforward reasons. One possibility is that there's been a change in how much water gets to the geyser's underground pool. More water could mean more eruptions. Another possibility could be changes under the Earth's surface, small earthquakes rearranging the underground pathways, or more rain might add to the water pressure. Steamboat geysers' frequent eruptions raise new concerns, silent signs of a supervolcano's awakening. However, these simple explanations might not be enough to explain the ongoing changes. If none of these factors are causing the increase in eruptions, then we might be facing a more serious situation. The frequent and increasing activity of the geyser might suggest that the giant magma chamber underneath Yellowstone is getting busier and building up pressure. Yellowstone is known for sitting on top of a massive supervolcano, which has had 3 huge eruptions in its ancient past. The changing behavior of the Steamboat Geyser could be an early sign of another major volcanic event. Although this is just speculation for now, it's difficult to ignore the possibility that these changes in geyser activity might be the park's way of warning us about potential volcanic activity. Considering the past, the signs we're seeing from the Steamboat Geyser are not to be taken lightly. These natural indicators could be pointing to a significant increase in underground volcanic activity. The idea that these are mere coincidences seems less likely as the geyser's behavior continues to evolve. It's important to monitor these signs carefully, as they could be critical in predicting and understanding what might be developing beneath the surface. This supervolcano isn't just a fascinating geological feature. It's a serious danger that could potentially cause widespread devastation. The park sits atop a massive underground reservoir of molten rock, and recent signs suggest that this volcano could be growing more active. One of the most noticeable signs of potential trouble is the behavior of the Steamboat Geyser, which has been erupting much more frequently than usual. Historically, this geyser's eruptions were rare and unpredictable, but now it seems to be erupting several times a year. This change in behavior could indicate that the volcanic activity underneath Yellowstone is increasing. The area over the supervolcano is monitored closely by the Yellowstone Volcano Observatory, established in 2001. Scientists there keep track of ground movements, record earthquakes, and measure the gases released by the Earth. These measurements are important because they help predict what the volcano might do next. However, despite their efforts, there's a feeling that more needs to be done to prepare for a potential eruption. Monitoring the volcano is crucial, but informing and preparing the public is equally important. The government needs to take a more active role in raising awareness about the supervolcano. People need to understand what could happen if it erupts and what steps they should take to stay safe. Right now, there seems to be a lack of urgency in communicating these risks to the public. Furthermore, the park's frequent ground shifts, temperature changes, and gas emissions are not just natural curiosities. They are signs of the immense forces at work beneath Yellowstone. These signs should be taken as serious warnings, not just interesting phenomena for visitors to observe. A comprehensive response plan is critical. This plan should include detailed public education on the supervolcano, what signs precede an eruption, and how to respond if one occurs. It should also involve improving the infrastructure around Yellowstone to handle an emergency, like roads that can accommodate a sudden influx of traffic as people try to leave the area quickly. Every year, the United States government allocates significant funds for various safety measures to prepare for natural disasters and security threats. In 2023, the Federal Emergency Management Agency received about $2.7 billion for disaster relief efforts. Additionally, more than $15 billion was set aside for homeland security initiatives, which cover areas such as counterterrorism, infrastructure protection, public health, and pandemic preparedness. The Centers for Disease Control and Prevention, CDC, was allocated approximately $8.7 billion to manage and prevent health crises. Despite these substantial investments in safety and security, funding for supervolcanoes like Yellowstone is considerably lower. Supervolcanoes represent some of the most powerful and destructive types of volcanoes on Earth, yet they receive a fraction of the budget that other safety measures get. The Yellowstone Volcano Observatory, tasked with monitoring volcanic activity and conducting important research, operates with limited resources. This makes it difficult to fully assess and prepare for the potential dangers posed by supervolcanoes. Considering the extensive damage a super eruption could cause, it is crucial to understand the risks and have robust preparation plans in place. An eruption from Yellowstone, for example, could have catastrophic consequences, affecting huge areas and disrupting millions of lives. However, the current level of preparedness and funding does not reflect the severity of the threat posed by such an event. Apart from Yellowstone, other supervolcanoes exist in the United States, such as the Long Valley caldera in California and the La Garita caldera in Colorado. Around the world, significant supervolcanoes include Taupo in New Zealand, Toba in Indonesia, Aira in Japan, and Campi Flegrei in Italy. Each of these has the potential to cause immense destruction. Despite this, the attention and funding directed towards supervolcanoes are not adequate. The disparity between the budgets for more common disasters and these colossal volcanic threats is striking. The limited budget for supervolcanic monitoring and research stands in stark contrast to the billions spent on other safety measures. This discrepancy raises important questions about our priorities and readiness to handle a supervolcano eruption's impacts. As we continue to monitor signs of volcanic activity, the need for increased funding and resources becomes more apparent. Enhancing our preparedness for such a major geological event is essential to mitigate risks and protect populations. Without sufficient support and attention, we risk being unprepared for a disaster that could reshape regions or even have global consequences. Volcanoes like Italy's Campi Flegrei and Yellowstone in the United States are well known for their potentially catastrophic power, often labeled as supervolcanoes because of their history of enormous eruptions. For instance, consider the Toba supervolcano in Indonesia. Roughly 74,000 years ago, it experienced a massive eruption, releasing about 672 cubic miles of volcanic debris into the atmosphere. This eruption was the largest of its kind ever recorded and resulted in a volcanic winter that drastically reduced temperatures across the globe. The prolonged cold and resulting climate changes led to widespread famine, drastically reducing the number of people who survived, thereby affecting the genetic diversity of humans. The threat of supervolcanoes extends far beyond Yellowstone. The hidden power beneath New Zealand's landscape. Another significant event in volcanic history is the Orowanui eruption from the Taupo supervolcano in New Zealand, which happened around 26,500 years ago. This eruption expelled approximately 280 cubic miles of material, blanketing much of New Zealand's North Island with a thick layer of ash. The ash and other ejected materials had a devastating effect on the region's plant and animal life, significantly altering the natural landscape. This event is preserved in the oral traditions of the Maori people and was even noted in ancient Chinese writings, which described unusual red skies and other climate anomalies thousands of miles away. The terms massive destruction, climate change, and environmental devastation often come up when discussing supervolcanoes. Comparing Yellowstone to Toba, it might seem that Toba was more destructive due to its more recent activity. However, experts warn against underestimating Yellowstone. The long periods without eruptions at such volcanoes might suggest that they are accumulating a large amount of magma, which could lead to extremely powerful eruptions in the future. The last major eruption of Yellowstone occurred around 640,000 years ago, significantly longer ago than Toba's last eruption. This long dormancy period might mean that Yellowstone is gathering a much larger amount of eruptive material compared to Toba. If this is true, the consequences of an eruption could be much worse than we might expect. The presence of volcanic ash and gases in the atmosphere would be the least of our worries. The real danger would be to agriculture, as the ash and sulfur could contaminate soil and water, making it impossible for farms to produce healthy, edible crops. This would not only affect food supply, but could also lead to a dramatic increase in illnesses related to air and water pollution. The history of these volcanoes teaches us about the powerful forces at work beneath the Earth's surface. While they add fascinating chapters to our planet's geological story, they also serve as a stark reminder of nature's ability to dramatically alter our environment. Scientists continue to monitor these volcanoes closely, trying to predict their next eruptions. Meanwhile, those living in the shadows of these giants face a future filled with uncertainty, hoping that the next chapter in the volcanic history books remains unwritten for a long time. Imagine the powerful Yellowstone supervolcano suddenly erupting with an intensity that surpasses most natural disasters recorded in history. Typically, a visitor to this national park might worry about minor inconveniences such as food-related illness or avoiding unexpected falling rocks. However, the threat posed by this volcano is far greater and could impact life on a massive scale. What complicates this scenario further is the difficulty in predicting how long such an eruption might last due to the complex natural processes involved. The destruction caused by an eruption of this magnitude would not be contained within the United States. Looking at previous eruptions, we know that the volcanic material can travel far beyond the U.S., affecting areas as distant as Mexico with its ash and debris. Scientists are currently working hard to build models that can predict what might happen, but there is still much that remains unknown. Now, let's consider an even more severe scenario. What if, instead of just Yellowstone, 10 of the world's 20 known supervolcanoes were to erupt at the same time? The thought itself is overwhelming. Each of these volcanoes, like Yellowstone, Toba, and Taupo, has the potential to release enormous amounts of ash, gases, and molten rock. If all 10 erupted simultaneously, the effect would be unimaginable. This life-threatening event would release so much volcanic ash into the atmosphere that it could block out the sun for months. This would lead to a significant drop in temperatures around the world, disrupting global climates. Such drastic changes would halt the growth of crops, leading to severe food shortages. Essentially, this could trigger a catastrophic chain of events, transforming what we consider a natural disaster into a global crisis that could bring about a widespread collapse of societies as we know them. The impact of such a disaster is hard to overstate. It would not just be a series of eruptions, but a profound crisis that could halt the progress of modern civilization almost overnight. The mere possibility of one supervolcano erupting is daunting enough. The reality of multiple eruptions could be far more devastating. Could Yellowstone's supervolcano eruption be the next global catastrophic event to reshape our world? Leave a comment and subscribe for more.